All right, today we would like to solve ODE of the following form. So solve ODE of the form P dx plus Q dy equals 0, where P and Q are functions of x and y. Of x and y. And in fact, you will see lots of ODEs can be put in this form. For instance, let's do it with the following ODE. Consider not dy over dt, but in this case, dy over dx is minus 2xy plus y squared, and then x squared plus 2xy. This will be a model problem, as you'll see. And in fact, to put it in this form, let's first cross multiply. So you get x squared plus 2xy dy equals minus 2xy plus y squared dx. Not quite of this form, but if you put the dx on the left-hand side, then you then get 2xy plus y squared dx plus x squared plus 2xy dy. So your p would be 2xy plus y squared, and your q would be x squared plus 2xy. And if the notation p dx plus q dy looks equals 0 looks familiar, it's because it is, because it turns out it's the same notation you use to deal with line integrals in multivariable calculus. So the next video will actually be a tool of the multivariable calculus tools that we'll need. I guess a review of the multivariable tools.